So now we get to balancing equations. So at the heart of balancing equations is this idea that atoms are conserved, meaning atoms don't get destroyed, atoms do not get created. So just like the Lego blocks, you may want that special Lego block that you don't have, but you can't just make it appear out of nowhere. Atoms are neither created or destroyed, and the same number of each kind of atom is found in the products and in the reactants. So how do we determine what the reactants and products are? We do this by observation. So we establish by observation what the reactants and the products are. And that's not really going to be up to you guys to decide what the reactants and products are. We're just going to balance the equation. So we've already established what the reactants and the products are, and then we can't just change those formulas. The identities of the compounds, the formulas of the compounds, can never be changed when balancing a chemical equation. It's tempting sometimes to just change it, but then you're describing something different, which may or may not actually happen. So here are the steps in balancing equations. So first you need to read the description of that reaction, identify what the reactants are, what the products are, what their states are, and then write out the appropriate formulas. So here's another example. Hydrogen gas and oxygen gas combine to form liquid water. So here's one reactant, hydrogen gas, and the formula for that would be H2, because hydrogen is a diatomic element. And oxygen gas. So oxygen is also a diatomic element. Its formula will be O2. And they're going to combine to form liquid water is going to be the product. The formula for that is H2O. So then, after we identify what the reactants and products are, we write an unbalanced equation. So here's H2. We were told that it was in the gas state, plus O2. Let's change the color here. So in the sentence, hydrogen gas and, that's like plus, combine to form, that's the arrow. So those are the words that can give you a clue. So we've got hydrogen plus oxygen forms liquid water. So we're just translating that into this equation form. We'll get rid of all the words, and then we can just see the formulas. Oh, this plus this makes that. It's kind of like a shorthand. And then we balance it by inspection. Balancing equations is something that we can give you guidelines for, but I can't give you a hard and fast set of steps to follow blindly that will always give you the right answer. So you have to just think about this a little bit. Balancing by inspection means you look at it and see what needs to be done. One guideline is to start with the most complicated molecule. Didn't mean to do that. Starting with the most complicated molecule. So we're going to look at this and we see that the equation is unbalanced. H2 and O2 making H2O. You have to examine or inspect them and see, well, how many H's do you have to start with? Well, I'm starting with 2, and how many H's do I end up with? I'm ending up with 2. Great, that's fine. I'm starting with 2 O's, and I'm ending up with 1 O. That's not fine. So the equation is unbalanced. We look at it and see that, okay, there's something wrong here. So then we're going to balance it by adding more molecules of reactants or products, whatever we need. You can't take things away. All you can do is add things. So if we look at this here, now we were short on oxygens in our product, so if we add another water molecule, now we've got the right number of oxygens. We've got 2 oxygens, but now we messed up the hydrogens. Now we've got too many hydrogens. So then we add something else. That means we need to add more hydrogens over here. And you keep doing that, just adding what you're short of until you end up with things balancing. So it's a little bit like this is a teeter-totter. So if you imagine this, let's see, I need this to be wider. If you imagine this to be a teeter-totter, it's balancing where the arrow is. And here I've got 2 H's on one side, but I've got 4 H's on the other side. That's not going to balance, right? It's going to flop to one side or the other. So we're going to make adjustments to our teeter-totter so that now we've got 4 hydrogens there and 4 hydrogens there and 2 here and 2 there. And then it will be balanced. It's equal on both sides. So that's one way to look at it. The other way is to think of the atoms as being Lego blocks, and you have to account for all of the ones that you started with. So by adding another hydrogen to the reactants and another water molecule to the products, we end up with them balanced. And so we're going to combine these two and call it 2H2, and we'll combine these and call it 2H2O. So here's our balanced chemical equation in the red box. 2 hydrogen molecules plus 1 oxygen molecule gives us 2 water molecules. So at the end, check that the coefficients used give the same number of atoms on each side. So make sure that it's balanced. Check your work. The number that we put in front of the formula is called a coefficient, and that multiplies the whole formula. You cannot go in here and change the subscripts. That's changing the formula, changing the substances, and you just can't do that. Sometimes you'll end up with a balanced equation like this. This is balanced. Here we've got 4 times 2, 8 hydrogens over here, 8 hydrogens over there, 4 oxygens over here, and 4 oxygens over there. It's balanced, but we prefer that these coefficients be in the lowest ratio. So the ratios on this one are 4 to 2 to 2 to 4. And if we divide all those numbers by 2, we end up with 2 to 1 to 2, which is better. So this equation is balanced, but this is better. This one's not wrong, but this one's better. Any questions? So let's do an example. Balance the following equation in standard form. And by standard form, they mean the lowest multiple integers, the lowest ratio. And it says determine the sum of the coefficients. So I give you multiple choice exams and balancing equations and testing that with multiple choice. There's a couple of different ways you can do it, and this is one way. So let's ignore the whole multiple choice aspect and let's just balance this thing. So we have to look at it. And it can be helpful to just sort of tally up what's going on here. So I'm just going to draw a line down here to separate the reactants and the products. And then I'm going to kind of make a list over here of the different elements that I have. I've got iron and I've got oxygen. So in this first compound, how many iron atoms are in that formula? Just 1. So under that guy, this is 1. And in this guy, how many oxygen atoms are there? 1. And over here in O2, there are 0 iron atoms. And there are 2 oxygen atoms. So our total for oxygen over here is a total of 3, and our total for iron is 1. Now you may want to do all this scribbling when you first start balancing equations. And then once it becomes clear to you what's going on, you probably won't have to do that anymore. Then I'm going to go look at my product, Fe2O3. In one molecule of this, I have 2 iron atoms, and I have 3 oxygen atoms. So I've just sort of taken inventory of both sides to see, okay, with no coefficients, how many of each am I starting with, and how many am I ending up with? Sometimes it's balanced without any coefficients. Usually not. That would be too easy, right? So we look at this, we compare these numbers in. So this is showing us we're starting with 3 and we're ending with 3 oxygens. Great, that's fine. But the ions are not balanced. We're starting with 1, we're ending up with 2. That's impossible. You can't have an iron atom just poof appearing out of nowhere. So how can we fix that? Well, we must be starting with 2 iron atoms. So I'm going to put a large number 2 in front of FeO to say, well, actually, we started with 2 molecules of that. Then I have to adjust my totals. Because if I have 2 of these, then I have 2 there, not just 1. Right? I've got 2 of those and 2 of those. And then 2 plus 0 is 2, and 2 plus 2 is 4. So now I look and see how's that working out. Well, I fixed the irons, but I screwed up the oxygens. That doesn't necessarily mean you're going in the wrong direction. Sometimes that's just how it works out. So you say, well, okay, now what? I fixed that, fixed the one, I messed up the other. So let's go fix the other one. Well, we need to get more oxygens on this side. There's only one way we can do that. We have to make 2 of these guys. We can't just change that 3 to a 4. Really tempting, but we can't do that. So let's use another color, maybe orange. So I'm going to put a 2 here. You see that okay? And that changes the numbers below. If I have 2 molecules of Fe2O3, now I've got a total of 4 oxygens and, 4 irons and 6 oxygens. Right? Because this number 2 multiplies that 2. 2 times 2 is 4 irons, 2 times 3 is 6 oxygens. So now I've succeeded in messing up both of them at the same time. We're making progress here. We are. Well, which one should we try to fix first? Fix the more complicated one first. So this molecule has 2 different elements. This only has 1 element. Let's leave this guy for the end, because when we change that, we're not going to mess up anything else. When we change this one, we're going to change 2 different elements. So let's fix this one first. I need 4 iron atoms, and so over here I need to change this 2 to a 4. And now I'm going to have to use the magic eraser. So now in 4 molecules of FeO, I've got 4 iron atoms and 4 oxygen atoms. You with me? Now I'm going to check my totals, because these have changed also. So let me erase those. 4 plus 0 is 4. 4 plus 2 is 6. And then I'm going to compare these numbers. Oh, cool. There it is. Sometimes you feel like you're going around in circles. If you go around in circles more than twice, you might have something off. Usually you don't have to go around more than twice. So this is now a balanced chemical equation. 4 FeOs plus 1 O2 is going to give us 2 Fe2O3s. Now, the question is asking for the sum of the coefficients. And when you do that, you have to have the lowest multiple integers. Well, what are our coefficients here? This is a 4. Is there a number here in front of the O2? There's a 1 that we didn't write because we don't write ones. Okay? And here's a 2. And so our ratio then is 4 to 1 to 2, which is the lowest ratio possible. So then the sum of the coefficients is 4 plus 1 plus 2, which is 7. The tricky thing about doing a problem like this, and they were kind in the answers, they didn't put 6. It's common for students to overlook that there's an implied 1 there. When you're adding up coefficients, it's not just 4 plus 2, it is 4 plus 1 plus 2. Any questions? I just couldn't remember what was coming up. Okay, let's do this one real quick. Which of the following correctly balances the chemical equation? Okay, well, let's just go ahead and balance it before we look at the choices. Sometimes that is better. So I'm not going to do all that tallying. I'm going to show you how you can do this without doing all the tallying stuff. So I'm going to inspect this. I'm going to look, so calcium. Over here on the left side of the arrow, I've got 1 calcium. And over here on the right, I've got 1. So that's good. Here, oxygen, I've got 1. There's none here. So total of 1 oxygen. Over here, I've got 2 oxygens. So let's try just fixing that right off the bat. I'll put a 2 here. So now over here, I've got 2 oxygens, and over here, I've got 2 oxygens. But I changed the calciums. So I need to go back and address that. So 2 calciums, only 1 calcium. So I need to fix that. Put a 2 there. When I did that, I did not affect the oxygens. So I'm kind of mentally keeping track. I did calcium and oxygen. Those guys are cool. Now I'm going to look at the carbons. And on this side, didn't mean to do that. On this side, I've got 1 carbon. And over here, I've got carbons in 2 places, right? CaC2. So there's a total of 4 carbons right there, and there's 1 over here. It's a total of 5. On the left side, I only have 1. So I need to put a 5 in here. So that's the more advanced demonstration of balancing by inspection. Most of you are not going to be able to do that right off the bat. So I balance the equation. Now I look for the correct balanced equation. Well, which one matches up with that? Number 2 does. But it says there may be more than 1. Well, what's the difference between 2 and 3? 3 has all of the numbers from 2, all the coefficients divided by 2. 2 divided by 2 is 1. 5 divided by 2 is 2.5. 2 divided by 2 is 1. 1 divided by 2 is 0.5. So those aren't whole numbers. Is that okay? Well, it's not ideal, but it's balanced. Okay, so this one is also balanced. How about number 4? What's the relationship between these coefficients and these coefficients? They're doubled. So 2 times 2 got us 4, and 5 times 2 got us 10. 2 goes to 4, 1 goes to 2. This is also balanced. Is the first one balanced? No. What did they do? Well, technically it's balanced, but it's not. What did they do? They put a 2 in here. You can't do that. Because calcium and oxygen form a compound in which there's 1 calcium and 1 oxygen. You can't have CaO2. So this one is balanced, but it's not correct because they changed the formulas, and you just can't do that. Then the next question is asking us which one is preferred, and that's this guy with the lowest ratios. That one's the best. So remember, you have to have the same number of atoms of each element on both sides. You cannot change the subscripts. The balanced equation is giving us ratio of number of molecules. And coefficients can be fractions or decimals, but usually we prefer lowest integer multiples. Ta-da! End of chapter.